Hey guys, so I got this circuit here. Thought there now. I just gotta get to work here quickly here. Well, you can see this is 9 hours and 9 minutes here. It's been running. You can see how the batteries react right off the bat, and then everything stabilizes. These are 3 minutes on and off. So the top voltage here is 14.436, and this is the other battery. When they flop, 14.407. I'm gonna come over here to the last one. 14.436. 14.407. 04. So you can see how it's stabilized. It's the last 14. 436. And that, like what I'm showing here is two batteries. They get parallel together. So, and then they get put to the input, the motor. See, everything's all hardwired here now. There, they just flipped. They flip it every 3 minutes. Now it's at 14.44. And this is rising because now these other two batteries that are being used, whichever two they are, have a little bit of a higher voltage when they're parallel together. So, and now the other two are in series getting charged. And they change over like that every 3 minutes. So I gotta get to work quickly. So yeah, so there's the current going in. It's probably, I don't know, on that gauge it's like 20 milliamps or so. Should actually have a cap in there too, but ring's just hardwired up here now. Showed this morning. So this has been going for about 18 hours here, 1748. You can see it's sustaining itself. And it's under load. There's the load on it. So here, you can just see this is where the batteries just came down and leveled out. But now it's sustaining itself. Actually went up a bit here. Just how batteries are, they'll kind of go up and down in waves. But this is just with two batteries on the output in series. Ideally I'll have 3 or 4, which I'm going to do that here quickly. I'm going to bring the circuit up a bit so I have either 3 or 4 of them on the input, or on the output and on the input. So I'll be paralleling 3 of them together and have 3 of them in series on the output. Probably start with that. Keep working my way up, because I know that's where I get the best results. As it is right now, it's already sustaining itself. Well, it's under load. I know in the past I used to do it with the lead acid batteries, and the big motor I had was with a mechanical. It had brushes and a commutator type of switching. It was really simple and easy to make too. I used a welder and everything and made it out of heavy duty steel. And slip rings from the car alternators is what I used for it. Brushes too. It's probably better than this anyway, like for a longevity. I'd say that's the way to go if you're gonna make one of these. I'm also gonna design the circuit with the 555 circuit for switching. I'll be getting rid of this. But you don't need this. What is nice with this though, you have the inching feature, which I use to turn it off right away. So it's only on for a second and then it turns off, so it burns a little less power. But with the 555 circuit, I can make it run on 10 milliamps instead of 40 or 50 with this one is drawn. I might just have the 555 circuit running as a timer so it can turn this one on when I need it. But I don't know what I'm going to do here yet. But just, I've already saved this, so the computer's pretty slow because I put a hard drive in it. The SSD failed, so it's really slow with a hard drive. Those little blips that you were seeing too on like going down there, forgot to mention it. That's from when it switches. The voltage has enough time to drop a bit. I'll leave this run. It'll be a continuous running. Many of hours I leave this stuff run. I don't just do a 12-hour test and take my data from that. I'll leave it run. But anyway, I'll be gathering more data with this one. I'll probably try to do about a 50-hour run with these 4 batteries. And then maybe move it up to 6. But anyway, thanks for watching, guys.